Thanks everybody for coming out to building AI-enabled web apps at the MISC track here. So I think that you found the right place. My name is Colin DeCarlo. I guess by this point in my career, I couldn't consider myself somewhat of an elder developer. I've been working on the web for about 20 years now. Going back maybe 10 years, 12 years ago, I learned that working alone wasn't very good, so I started a local PHP meetup. And ever since I've been organizing that PHP meetup has been going really well every month. So the not so dirty secret is, I'm a PHP guy talking at a JavaScript conference. I think for the next 45 minutes or so, we can still be friends though, right? I appreciate JavaScript quite a bit. More of a PHP guy. Now, I work at Vehicle. We're a sponsor here at the conference. We're a software consultancy with over 75 team members specializing in Laravel and JavaScript. We've been a premier partner of Laravel for over a decade now. We've worked with customers of all sizes, augmenting their internal teams to help them ship code and deliver faster ROI to their clients. Our goal that we say at Vehicle is to make you look like a superstar to your team and to your stakeholders. And I honestly believe that we deliver on that every single day. Now, here's a free piece of consultancy. If you want to do a talk at any conference, really, any tech conference, between now and maybe the next couple of years from now, just say that it's about AI and you'll probably get that spot. Now, why is that though, right? Like, why can you say that this talk is about AI and pretty much guarantee a spot at a conference? I think it's because right now in this room and in our community, not too many people really know what's going on with AI, how to work with it, use it. So like nobody knows, right? That's a pretty bold statement, right? And so if I'm going to say something like that, let's see if I can back that up. As a PHP person, I wasn't too sure, honestly, where the JS ecosystem was in terms of their adoption with AI. So I figured I'd go to NPM and just do a keyword search for LLM and see how many results I got back. And this is when things, for me, started looking a little bit like not a good argument. There were 730 packages that I found, just tagged with LLM. You know, seems like a lot, right? But then I remembered, this is JavaScript, right? So let's dig into the numbers a little bit more and see what they say. So the first result in that search was LangChain, right? We're looking at downloads per week. And LangChain, if you're not familiar with it yet, is a framework that's a port of a Python framework of the same name. And what it does is it abstracts over the different AI providers like Google, OpenAI, Anthropic, and gives you a framework for working with them in an abstract way. So LangChain gets about 6,000 downloads per week, which is pretty significant of things. Now, the other 700-ish packages put together get about 535,000 downloads per week. So there's one standout in this group, right? And that's LangChain. LangChain is a framework. Frameworks are supposed to make things easier for you. I thought, let's get some comparisons to other frameworks. So let's look at build frameworks. Do we have anybody that uses Grunt still? I didn't think so, right? Grunt was last published about 2 years ago, and it gets 691,000 downloads per week. That's about 100,000 more than LangChain already. Gulp, any Gulp users? No? Oh yeah? All right. It's safe, it's okay. Gulp gets about 1.3 million downloads per week, right? So that's build frameworks. What about popular front-end frameworks? What about React? This is React. So let's fix the scale there. React gets about 22 million downloads per week. So if we compare that to LangChain, the leader in AI right now, that's about 40 times more per week, 40 times less LangChain is getting. So I think in terms of adoption, right, as an adoption curve, where we are as a community across different languages, PHP, JavaScript, those sorts of things, is right here with the early adopters. Which means at this point, nobody really knows. We're just trying to learn how to use these tools, right? And that's fine. I mean, like, for me, working with AI, in the morning, sometimes I feel like I'm going to end up with a system that is comparable to something that we see right here, only a couple hours later to be completely discouraged and feel like I've cobbled together something that looks like this, right? Big difference, but I'm just learning, right? So this talk isn't going to be narrowly focused on one single aspect of AI. What I'm going to do is talk about a number of ideas and concepts that will hopefully fill some gaps for you and just get you excited about building AI-enabled web apps. And to do that, what I'm going to do is I'm going to talk about 2 demo apps that we built at Vehicle just with the sole purpose of learning how to build with AI. So the first one we're going to talk about is Ask the Docs. It's a semantic search tool for the Laravel documentation. Our goal with Ask the Docs was to be able to ask a question just in plain English and get a well-written and correct answer from an LLM that was based solely on the information that is in the Laravel documentation. Now, the other app is an AI assistant. It's just a chatbot, and we developed it to get a better understanding of how function calling is currently working. So basically with this, you can ask for the weather and it will tell you what the weather is and then ask if you want that emailed to you. So let's dig into Ask the Docs. This is the biggest part of the presentation. We're going to go over a number of concepts here. And as I mentioned, Ask the Docs allows you to ask questions about how to do something in a way that you would ask a pair partner or a mentor. So a quick example is you could say, I want to add 2FA to my application, and how do I do that, right? What Ask the Docs will do is it will gather up all of the relevant information that it has in its own database about your question from the Laravel documentation, package that up, and then send it over to the LLM to answer. The LLM will then read that information, get an understanding of what it is, and then present to you an answer based on its understanding of how to accomplish your question, right? So something to point out is that these aren't excerpts from the documentation. This is the LLM's understanding of how to actually do what it is you're asking for, right? Based on the documentation that we gave it. So we built this last year. We're continuing with it in 2023. And we wanted to answer the question, what can we build knowing just the tools, or what can we build with AI using just the tools that we know how to use already? So we built this using Laravel, Inertia, Vue, Tailwind, and Postgres as our database. And along the way, we learned 3 important concepts that I'm going to share with you today. We learned about prompting, vector embeddings, and retrieval augmented generation, or RAG. So let's talk about prompting. Again, here's the adoption curve. And I think by this moment, it's safe to say that nearly everybody in this room has probably interacted with an LLM using a tool like ChatGPT, right? The technical term for providing input to a generative model is prompting, and an entire profession has actually sprung up around that called prompt engineering. Prompt engineering is there because they've learned that the quality of the prompt that you use can drastically improve the quality of the results that you get back from your model. So the saying goes, quality is everything, right? I can make an argument that as cheap as I am, I'm going to make a better tasting salad if I buy my vegetables from a local farmer's market. I'm going to make an even tastier salad if I put in more work, do a little bit more effort, drive down the road and visit my cousins on their organic farm and buy my vegetables from them. That's actually my face. So the bottom line is you got to invest a lot into your prompt, because you can't just buy one at Temu and expect to use it next year. So a good prompt will set up the model to provide reliably consistent responses. So this is a distilled version of the prompt that we use for Ask the Docs, and from it I want to highlight 4 important component parts of it that make up a good prompt. So the first thing you want to do is give the model an identity. So this will set the model's personality. So what we wanted to do was have an enthusiastic and happy Laravel expert answering our questions. So that's what we told it that it was. What this will do is this will make the results that we get back from the model just more predictable. Now, the next section is the instruction. This is the most important part of your prompt. So this is where you should invest most of your time and your effort. The instruction is something that you want to make clear of ambiguity. You don't want the model making any assumptions at all. So you want to make sure that you provide examples. Think of possible edge cases that your users would run into asking their questions, and make sure that you cover it here in the instruction. So after the instruction we have the condition. Now, if you provide a model with an input, it will provide you with an output. And sometimes those outputs aren't necessarily correct. And that's what we call a hallucination. So if you provide the model with a condition of what to do when it doesn't know what to do, it can have a way out. It's like putting an else clause in an if-else ladder. And then finally, the thing that we want to specify is the output. So this is all about predictability again. If you don't specify what output you're going to get from your model or what you want it to give to you, then there's no way of telling what it's going to be when it comes back. And that's going to make it very hard to work with, very hard to process in your own programs. So this is what the code actually looks like for doing that. And if you look at the first line here by the return statement, we're using a property called OpenAI. And that is an instance of an object from the official OpenAI package, right? So people at OpenAI made an official JavaScript package, and that is really great. If you work with PHP, OpenAI doesn't really know that that exists for some reason, and so we have to use a community-supported package. Now, there are a number of parameters that you pass along with your request. And so there are two required parameters, though. The first one is the model, and that's the model that you want being used when the request is being processed. And when you set the model, what that does is that has an impact on the size of the context window that the model has to work with. It will also limit the output size that you get and control the overall costs of processing your request. The next section that you want to pay attention to is the messages property. And the messages property is an array of instructions and input and whatnot that the LLM is going to read, and this is what it's working with. And you can see that each message here has a role. Roles are important when communicating with the model, so let's just talk about them now. So there are system roles, user roles, and assistant roles. So as this is modeled as a chat, system role messages can be seen as invisible behind the scenes cues that you're giving to the model that's going to affect its behavior. It's going to take cues from that as to what it's supposed to do. So I like to think of system role messages as kind of like a director in a stage performance. They're the ones that are pulling the actors aside, telling them how they're supposed to be feeling, how they're supposed to be acting right now, and that sort of thing. Now, the other two roles are pretty self-explanatory. You have the user role, and that's what you would assign to input that comes in from your user. And then you have the assistant role, and that is what you assign to messages that come back from the model itself. What's really neat about assistant role messages, though, is they don't have to come directly from the model itself. You can seed your messages array with information, with messages from the assistant that it's then going to use as more instruction of how it's supposed to continue the conversation with your user. So for Ask the Docs, there was two other parameters that we wanted to make sure that we used. The first one was max tokens, and max tokens sets the size of the output that you get back from your model. So we set max tokens to about 1024, and so a token is about 4 characters in size. So we're dealing with about 4,000 characters. 4,000 characters is about 800 words, which is really just enough to read for an answer, we thought. We also set the temperature. And the temperature on a model is what's used to control the randomness of the model. It can be seen as its creativity. So that value can range from 0 to 2. And the closer to 0 it is, the more predictable the results that you're going to get back from your model are. And so we wanted completely predictable results. So we decided to set the temperature to 0. Now, the response that you get back when you make that request is something called a chat completions response object. And the first few properties aren't really much to write home to mom about. The most important thing there is the model, and that will list the exact model that was used to service that request. So it will be a little bit different from maybe the model that you requested to use. So like we use GPT-4o. This says, okay, well, we use GPT-4o version from 2024-05-13. Now, the meat of the response comes in the choices array. And this is the messages that you can then use to present to your user. Now, it's an array because if you want, you can specify to receive multiple responses back from the model answering that question. And you can pick from whichever one you want to use. Something to make note of is the finish reason. The finish reason here is stop. And what that means is that the model met a natural end to its generation. And then so this message is safe to pull out and present to your user if you want. There's one final property, and that's called usage. And that just tells you how many tokens were used in processing the request and in sending the response. All right, and this is what the code actually looks at. And knowing what the raw response looks like makes it a lot easier to work with. So make sure you read the API documentation. You can see here that what we're doing is we're digging into the first element of the choices array, popping off the content from that message and storing it in a markdown variable. We then take that markdown variable along with the user's question and something called an embedding, and we create a record in our database called a prompt. And that's for showing people and sharing and that sort of stuff. All right. So that was prompting. So to recap, prompts are sent as messages to the chat completions endpoint. Messages will have roles, and those roles are system, user, and assistant. And good prompts will have an identity, a clear instruction, a condition, and an output format. Let's move on to vector embeddings. So at their core, large language models are just computer programs running on machines, right? The primary goal of these programs is to interpret inputs in a way that would mimic the way that humans would interpret them. So essentially the objective is to generate responses that seem like these programs understand what we're actually sending them. And the key to this understanding is vector embeddings. LLMs convert their inputs into dense vectors of real numbers that capture the semantic meaning of the text that you're sending it. So this allows the model to work in language in a mathematical space, which computers are just good at. It's a process, though, to get to the embeddings, and it starts with tokenization. So just like how you and I read sentences, tokenization is all about breaking up large text into smaller, recognizable chunks called tokens. So the entire set of available tokens is what's called the model's vocabulary, and they're referenced as words. Modern LLMs use something called sub-word tokenization, where most tokens are larger than single characters, but not all tokens are whole words in and of themselves. So a large compound word could be composed of multiple tokens. Each token is also given a unique ID in the vocabulary, and the tokens themselves have their own vector embeddings which capture their meaning as well. So a more practical example, this sentence here, when it's tokenized by OpenAI, looks like this. So you can see most of the tokens are whole words, but OpenAI got broken up into two. GPT-4o got split up. PT is by itself, which is kind of neat. Maybe that's like pterodactyl or something. But yeah, that's how it gets tokenized. Now, these tokens are then processed in order by the model, and they're used to generate an embedding, which again captures the semantic meaning of that whole sentence. So embeddings are something that you're supposed to understand the concept of. You know what they are, but you're not supposed to actually recognize them and use them. So like this embedding for this sentence is actually an array of 1,536 floating point numbers, which, if you think about it, is pretty obvious, right? So, but I do think it makes sense, right? Language is wildly nuanced. And so if it is wildly nuanced, being able to capture the meaning of that language is going to take a lot of processing. And a lot of processing is just going to mean a lot of data. So here's an example. This isn't Minecraft art. This is just a low fidelity image of the Atlanta skyline at dusk. It doesn't have a lot of data in it. You can kind of make out what things are, but if we apply more processing and more data, we get a much cleaner picture of what it is, and we can understand a lot more of what it is we're looking at, be able to pick out things. So embeddings that are semantically similar together, they'll cluster together, and then you can calculate the angle between them, individual vectors. And the smaller the angle between those vectors, the more similar they are to each other. So this makes them good for building things like recommendation engines, classification systems, and in our case, using them for semantic search. In practice, though, to effectively work with embeddings, you need to be able to store them in something that understands what they are and knows how to manipulate them. So there are a number of specialized vector databases that you can use, but thanks to an extension called pgvector, you can also store these embeddings into Postgres, which is very good for me. Better yet, the same people that made pgvector, they made extensions that bind into what seems like every single JavaScript ORM that's available. I choose to use SQLize for my examples here, and the pgvector binding allows me to work with it in just the same way I would any other data type that's supported by SQLize. So it's very helpful in that aspect. Unsurprisingly, creating an embedding is nearly identical to how a chat is created. So using the OpenAI package, you access the embeddings object and call its create method, passing in a payload that has two parameters. So the first one is the model. Well, the second one is the model. And that is the model that you want to use to create the embedding with. And then the input is what you want to create the embedding of. Now, the input here can be overloaded. It can be an array of strings, or it can just be a single string. And so I've only ever used a single string, but again, you can use arrays as well. So the response that you get back is called an embeddings object. And the embedding that we're after from that request is buried right here, and it is in the top level data property. So also, we've got the same usage object here that tells us how many tokens were used in processing that response. So as with the chat example, the results object will wrap that raw response and allow us to navigate it easily using object notation. So here we are getting the embedding out from the assistant and storing it in the result. And now working with it, if we want to, we can just dig into the data element, get the embedding, and then pass it into the set method of our record that we want to update with any other information that we want, and then call that record's save method. So that's working with it with a database. All right, so let's recap vector embeddings. Vector embeddings are created using the embeddings endpoint. Vector embeddings capture the semantic meaning of their input. Vectors are giant arrays of real numbers. And the similarity of vectors is measured by their distance, or the angle between them. All right. Now that we understand what embeddings are and they're in their database, we can use them for things like retrieval augmented generation, or RAG. Now, first, if you are curious about how in this day and age of social media and marketing, like literally anything could be given the term RAG, this is Patrick Lewis, and he's the man who's attributed for coining that term. And he too understands the misstep that he made when he coined that term. He says about it, "We definitely would have put more thought into the name had we known our work would become so widespread." And then also this one I think is actually pretty ironic. He said, "We always planned to have a nicer sounding name, but when it came time to write the paper, no one had a better idea." I mean, If only there was a tool that he could have used, like something that was trained on the entire English language that he could have gotten help from. I don't know, maybe a future like that might exist at some point. But as terrible as the acronym is, it is very accurate. So a typical flow between a person and a generative model is like this, right? We've all seen it. The user presents the model with a query. The model interprets that query and generates a reasonable response back to the user, and that is based solely on the information that the model has in its training data. So we call this straight up generation. In RAG, before the user's query is processed, the RAG system first goes to its database and retrieves relevant information from its own private dataset. This information is then integrated into the user's query, enhancing the input that gets sent to the model. So the model is now considered augmented, and that's because it has access to both its original training data and the data from the private dataset. So using both sources, the model generates a response that is tailored to our user's query that includes information from that private dataset. So this is what retrieval augmented generation actually is. So when Ask the Docs does RAG, what it does is it takes the user's question, how do I add 2FA to my login process? And the first thing it does is create a vector embedding of that. Now that we have the embedding, we can use it to find relevant sections of documentation that refer to authentication and two-factor auth. So for the sake of argument, let's say that this blue cluster here is the cluster of documentation that is related to authentication. And this dot here represents our user's question about 2FA. Okay? Now, mathematically speaking, every other embedding in the entire system is going to be related some way to that user's question. So what we have to do is constrain our result set by setting a threshold. And that threshold is going to limit the sections that we pull from the database about the user's question. Now, so that identifies these sections, and then they will be pulled out in an order that is most similar to the user's question. So the most similar result goes first in the result set down to the least similar, still within that threshold. So this is what the code looks like. You can probably all read it really well. So here we are. I'll make it a little bit bigger. Here we are getting the embedding from the user's question and storing it in the results object, and then stringifying that actual embedding and storing it into an embedding variable. Now that we have that embedding as a string, we can use it in the query that we send to the actual database. This is a lot to take in, so let's just zoom in on the actual SQL query, which in itself can be a little bit intimidating, especially if you're not that familiar with SQL. So there's one operator in here that I really want you to pay attention to, and that is this operator right here. This is called the inner product. And the inner product will calculate the angle between two embeddings or two vectors. And it will generate a number between -1 and 0, where the smaller that number to -1, the more similar those embeddings are to each other. So you can see it being used in our query 3 times. That's 4, 3 times. It's being used in the select statement, the second where clause, where we set the threshold, and then finally in the order clause, where we're saying order by similarity to these vectors. So we run that query, and we send it to the database, and it brings out the sections that we want to send along with our user's question. Once we have those sections, the next thing we need to do is construct the context that we're going to be sending to that model. And we do that here by just mapping over the sections, stringifying them effectively, and then joining them with new lines. Now that we have the completion, or the context, we can send it along with the completion and the user's question and get our answer. So you've seen this code before. This is that completions request. What I want to point out is that the context that we generated from the user, like from the database, is just a regular system message in the messages array. It's not anything different from anything else. There's nothing inherently special about it. It's just more information that the model can then use to generate its answer for the user. All right, so that is RAG, Retrieval Augmented Generation. Let's recap. RAG is a pattern used to introduce new data to the LLM for generation. Data is passed to the model as a system message in the prompt. Finally, similarity of vectors can be measured using their inner product. So I think now, though, we can probably all agree that RAG is like 10 minutes ago. It's boring, right? And what we need to do is we need to make RAG pop a little more. And we can do that using something called RAG fusion with multi-query. And this makes our RAG just better, generating better results. Things are going to get a little bit mathy in the next maybe 10 minutes, but hopefully to ground us in an example, here's a picture of a cute kid. This is my son, Isaac. He is my youngest kid. He has 3 older sisters. And to put things nicely for him, he is a very active boy, and he doesn't put a lot of cycles into forming good questions. So when he does ask me a question, it can be really difficult to actually understand what it is he's asking. So when his sisters come in, what they do, they have a lot more context about what he's asking because they're with him a lot more. And they can rephrase his question for me, give me a better understanding of what it is that he's actually asking, so I can give him a better answer. And that's basically what multi-query is. What we do with multi-query is we say to the LLM, if you were an expert in this specific topic, what are other ways that you could phrase this question? So that's what multi-query is, and hopefully you can see the similarity there. This is the prompt that we use for multi-query. We say, you are a helpful assistant that generates multiple search queries based on a single input query. The user is querying the Laravel documentation for answers. The query might be short. It's your job to try to understand what the user is asking for. If the query doesn't make sense, just say, I don't know. Give me 4 other examples of how to ask this question. All right, so why though? Why even bother? What's the benefit of taking the user's query and generating 3 other representations of it? It's because of the way that these individual queries rephrased will affect their embeddings, and the embeddings will affect the data that comes out of the database. The idea is that each query will create an embedding that's similar to, but not the same as the other embeddings. And because they're slightly different, the sections from the database will be different. I feel like I just said that. So they'll be different in a couple of ways, right? First, the sections that come out of the database, there won't be a complete amount of overlap of them. So there might be sections from the fringe of the threshold that are included in one data set, but not included in another data set, for instance. Also, because the embeddings are different, the similarity to the sections that are in the database will be different, and that will change the order that the sections actually appear in the result set. So that is the multi-query part of RAG Fusion. Let's talk about RAG Fusion specifically. You can see here that I've labeled all of the unique sections of data with IDs. So you can see here that ID A exists as the first element in the first data set, the second element in the second and the third element in the fourth data set. In RAG Fusion, the order is referred to as its rank, and the rank gets scored. The scoring system that we use in Ask the Docs is called reciprocal ranking. So we're doing reciprocal rank fusion. Now, this is one of those terms that sounds more intimidating than what it actually is. In reciprocal rank fusion, the score of an element in a data set sits between 1 and 0, and it's calculated with this formula here. The score is equal to 1 over its rank plus some constant k. Now, the constant is used to smooth out the gaps in the rankings and making the scores less significantly different. So, for instance, if we just said, okay, k is equal to 0, the difference in scores between the first and second element would be 1 over 1, which is 1, and then 1 over 2, which is 0.5. That's a difference of 50%. That's huge, right? That's a very uneven weighting. If we set k to equal to something like 60, which is typically used, the difference between the first and second ordered element is 0.0002 or 0.02%. Now, for simplicity, though, I am going to throw caution to the wind, and I am just going to use a ranking of 1 over r. So you can see here that I've ranked all of the elements in their individual data sets, starting at 1, then 0.5, 0.33, 0.25, and 0.2. All right, the fusion part of RAG fusion comes in the final ranking of all the elements. So the fusion score of an individual item is the sum of its scores across the data sets. So quickly, the fusion score for IDA would be 1 plus 0.5 plus 0.5 plus 0.33, giving us 2.33. So I've gone and I've ranked all of the fusion ranks of all of the unique items in the data set. Now that we have those, what we can do is we can take them all together in the aggregate, get the unique sections out, and then order them by their fusion ranking. And this gives us the order of the information that we're going to send along as context to the LLM. So we can limit it if we want, condense it down into a single string, and then send that out with the user's query to do our RAG. And we'll get better results doing something like this. That was RAG fusion. So to recap that, the LLM will generate multiple other queries based on the user's query. Embeddings are created for each query and data is retrieved for each of them. Individual scores are assigned to each piece of data that comes back, and they are based on rank. The overall score is given to each piece of data by summing the individual scores, and it's that overall score that is used in the final ranking. That's RAG fusion. All right, you've stuck with me. This is the home stretch. This is part 2. The next hour will be focused on AI assistant. No, it's just one thing. We have lovingly called our chat client Discount GPT. It's just a very simple chat interface, much like ChatGPT. We did build it this year, and we built it to get a better understanding of function calling, which OpenAI calls tools. And this represents something called agentic program control. All right. So what do I mean when I say agentic program control? I think to understand that, let's take a look at something that we are more familiar with: linear program control. With linear program control, you are in complete control of how input is handled in your system. You can map all of the inputs out to expected outputs. Ask the Docs is this type of system. We know what the input is going to be. The flow through the program is predictable. We can map all of the inputs to its outputs. Now, agentic program control, some of the control of the system is handed over to the LLM. So this type of system is better suited for varying and unpredictable inputs. Essentially, you tell the LLM that it has access to tools that it can use to answer your user's questions. And through its responses, the LLM will instruct your program to run various tools and respond with the user's output. So this is how the agent, the LLM, is controlling your program and the execution of what happens inside of it. So the tools that your program has available to it are passed along in the chat completions request. So it is good practice to tell the LLM in a system message that it has access to tools and to give a brief description of what each one of those is. The tools themselves are defined as functions, because naming is hard, and they are in the tools property. And those tools will have a name, a description, and a parameter and a list of parameters. What's really cool is that these are all done in plain English. There's no like cryptic formatting or anything like that. It's just English that explains the tools, and the LLM understands how to use them. You can also specify a property called tool choice, which will tell the LLM how it can use the tools. So you can say, use one tool, or don't use any tools at all, or take your pick at the tools that you want to use. All right, so let's do a discount demo of Discount GPT. Here's a simple back and forth between myself and Discount GPT. I'm just saying, hey, what's the weather like in Dallas? And it's responding to me with what the current temperature was at the time that I asked the question. Now, based on its training data alone, there's no way that the LLM was going to be able to answer this question. It would just say, I'm sorry, I don't know. Go check the weather network or something. But because we told it that it had access to a tool called Get Current Weather, it was able to request that our program use that function to check the weather for Dallas and then tell it what it's like, so then it can respond to us with the weather. So what does the back and forth between our program and ChatGPT actually and OpenAI look like in this interaction? Here's the messages that we have. Now, the first and fourth message you've seen before. This is where we set the identity for the model, and the fourth one is where we set the output. The second and third message is where we say, you have access to these tools, and don't make any assumptions at all about what parameters to call the tools with. Ask for clarification if you need it. And then the final two messages are the assistant message, just saying, how can I help today? And then our user's question, hey, what's the current weather like right now? Now, we have the tools array here. The tools is an array, and again, it is filled with functions. And the function definitions, you can see we've got a name called Get Current Weather. Its description is getting the current weather for a specific location. And there's two parameters that we're specifying, and only one of those is required. We're saying the required parameter is the location, where you want to check the weather for, and the format being the temperature unit to use. And we're allowing the LLM to infer what unit to use based on the location that the person is asking for. So because I was asking for the temperature in Dallas, Dallas is in the US uses Fahrenheit, I'm going to get an answer back in Fahrenheit. If I asked for my hometown, Guelph, which is in Canada, we use Celsius in Canada, and so I get an answer back in Celsius. All right, and then also we told it in the tool choice that you can just use any tool that you want to answer this question if you need to. So the LLM took that request and generated this response. Here's the header again. And the important thing is the choice. It gave us one choice. It's an assistant message, but there is no content. The stop reason is tool call, and that's because it's requesting that we make a request to a specific function that we're making it available. It wants to call Get Current Weather, passing in Dallas as our location and Fahrenheit as our format. So our program takes that, understands that it wants to make a tool call, and says, okay, now I'm actually going to check the weather, all right? So our program goes off and does that. Now, the important distinction here is it's not the LLM that's actually accessing the weather API. It's our program that has those credentials and holds onto it. We're just responding to the request that the LLM made to make that call. So our program goes off, checks today's weather, gets a response back from the weather API saying it's raining, like today, and that comes back in like a JSON payload, right? We can then take that JSON payload and create a new request that we're going to send along to the LLM. So this is a completely new request. It's not linked to the previous one programmatically. So we have to include all of the context from the conversation so far. So the first 6 messages are all the same, and the next 2 that we've got here is the assistant message from the response that we got, saying I want to call a tool, and then the last message has a new role of tool, and its content would be the JSON payload that we got back from our weather API. We're then linking the 2 messages together with that tool call ID, so the LLM knows this is the answer to that specific function call. So the LLM takes that information, understands it, parses the JSON, is able to give us a response back now with the finished reason of stop. So it says, oh, hey, the weather in Dallas is hot. What did you think? And there it is. We can then take that information and display it to our user. And that's what happens behind the scenes when we make a simple request like that of just asking what the weather is. So let's recap tools. Agentic program control gives control of program execution over to the LLM. Tools are included in the chat completions request. Tools are defined using natural language. The model requests tools to be called in the chat completions response. And then finally, messages with the role tool contain the results of the tool call. All right, we did it. That's it. This talk covered a lot of ground in a relatively short amount of time. Hopefully I've done a good job of explaining some of those concepts to you and got you just excited about the idea of building more AI-enabled web apps. I'll get your question, just one more thing. If you did find this content interesting, we are running a course called AI-drivenlaravel.com. You can go there. We have a weekly newsletter that is, for the most part, language agnostic. So you can learn all about different AI concepts there as well. So sign up, subscribe to the newsletter, and when the course comes out, we'll let you know as well. All right, so are there any questions? Yeah?
So with retrieval augmented generation, eventually the documents that are retrieved are just put into the prompt as context, additional context, along with the system prompt, et cetera, right?
Yep.
So I don't really understand what is so innovative about that in particular, because isn't that what search engines use to find similarity? It seems like it's like a search engine without an element.
Yeah. I mean, like Ask the Docs is a semantic search tool. A lot of other AI search engines are going to do something like this. What we're doing is search engines come from the point of like discovering information, right? Like, so we've been trained over the years on how to use search engines. Like, we use very short keyword phrases and whatnot, and we've gotten good at doing that. When you're making a request to like a semantic search tool that uses like this information, it's more about generating knowledge, if you can think about it that way. So that's really the difference. That's the innovation. It's not in how the information is pulled out of the database or anything like that. It's just in how that information is then processed and presented to a user. So like the information you get from the LM would just be more tailored to the results or to the question that you're asking.
Right, but the semantic part of it is a bit more advanced than just a keyword search.
Oh, absolutely, yeah. Are there any other questions? Yeah.
Yeah, in the fusion piece of the multi-query part, when you combined all the results based on the ranking from each question, how did you differentiate very similar results in the combination?
So because of like the data that we pull out of the database, like these are individual database records, so they'll have their unique identifiers, right? So that would be like just an ID in a column. And then so we would group, basically the whole algorithm is, once you have all of the data sets together, you would then group them by some unique identifier, like the database ID. And then you could then sum up the individual scores for the fusion rank. Anything else? All right, if you have any more questions, you can just find us at the booth and ask some questions there. There's a couple of other people that know a little bit more about this stuff. Again, thank you all very much. We covered a lot of ground here. Thanks.